All right, so the important thing, one more thing about the graphs of a to the x and log x base a, that just as we said that negative 1, 1 over a, 0, 1, 1a are all points of y equals a to the x, if we interchange these, we get that these points are going to be points are on the graph of log x base a, for example, and this basically just, these are just reflect the fact that a to the minus 1 equals 1 over a. These reflect the fact that a to the 0 is 1, and this reflects the fact that a to the 1 is equal to a. So that's why. All right, so now that because of logs, we can take inverses of certain functions. Remember how we do this. If we have a function of x, we replace x with y, set that equal to x, and then solve for y. So we write x equals 4e to the y minus 1. And if we wanted to solve this for y, the way we do this is we're first going to find what e to the y is. So we can add 1 to both sides and get x plus 1 equals 4e to the y. And then divide by 4. Okay? And now because of logs, if we know what e to the y is, we basically know what y is, because we can just take, this says that y is the number you raise e to get x plus 1 over 4. So that means that y is going to be the natural log of x plus 1 over 4. Okay. This is just the logarithmic statement of this exponential statement. Let's try this now. G of x is, so anyway, I should say that, so f inverse of x is going to be this. Okay. Now move to example B. We want to find the inverse of g if it exists, so we write x equals 2 plus the natural log of y minus 7. And now what we're going to do is we're going to isolate the natural log. Okay, so we can get the natural log of something equals something else, and then write the exponential version of that. So subtract 2 from both sides. And we already we have the log of y minus 7 is x minus 2. Now this says that x minus 2 is the log you raise e to get y minus 7. So we get y minus 7 is equal to e to the x minus 2. If we let this think about it for a second, okay, we're just this whole x minus 2 is the actual exponent. But these two statements are equivalent, and then we can just add 7 to both sides. Okay, so g inverse of x is going to be e to the x minus 2 plus 7. Okay. We're going to see the way we solve equations like this. If we can write e to the raised to something equals something else, we'll be in good shape. Or if we have the natural log of something equals something else, we're in good shape. Because in both those cases, we're like one step away from breaking it wide open. Sketching graphs. This is just more of what we did in the previous section and in the section on transformations. Just remember what the graph of the natural log of x looks like. It looks like this. So if we put a minus sign outside, we're reflecting it through the x-axis. Okay, and we'll the x-intercept is still going to be at 1. That's a reflection. Here, if we replace x with x plus 2, that's a reflection. That's not a reflection, that's a shift to the left 2 units. So we're going to be shifting the graph, and we're also going to be shifting the asymptote. So we're going to have an asymptote at negative 2. And you can sort of see that because x plus 2 is going to be positive as long as x is bigger than negative 2. Okay, and in particular, this point, the point at 1, instead of intersecting at 1 now, it intersects at negative 1. And the graph will look like this. Here we're taking log of x and we're shifting it up 2 units. Okay. The way we do that, well, we can see that this point up here, 1, 0, is now at 1, 2. Okay. However, the domain is still going to be we're just shifting this up, and then we're not, the graph is still going to be on the right hand side of the y-axis, so it looks like this. And then 1 minus x, here we do a couple transformations. We can replace x with x plus 1, and then replace x with minus x. And what that does is if we take this, we shift it to the left 1 unit. So we're going to get an asymptote at -1. Yeah, well, for the time being. And then we reflect it through the y-axis. This is a reflection through the y-axis, so it's going to be over here. And so, right, so it's good, and we can see the domain is going. If we set the 1 minus x to be greater than 0, we see that x is going to be less than 1. In particular, the log of 1 is when x is 0, we get the natural log of 1, which is 0. So the graph is going to go through this point. So yeah, so what we did is, okay, just like that. I think that should be right. This is probably the most difficult example, obviously. But yeah, it's good. We shift it to the left 1 unit, but then we reflect everything, so that's why this comes over here. Okay, so just keep in mind, you can't forget about our transformations.